Lesson 1. Scientific Notation and Large Numbers. Our objectives for this lesson. First is to reintroduce the concept of scientific notation, as this is something that you should have seen and learned already in your math classes. You'll also want to be able to write large standard numbers in proper scientific notation, as well as to write scientific notation numbers with positive exponents in standard notation. Before we start anything though, we need some vocabulary. The first is standard notation. Standard notation is the way that we normally write a number. So this is the way that you've been writing numbers ever since you first began to write. Scientific notation is a shorthand way of writing very large or very small numbers by using powers of 10. This makes life a lot easier, especially because some of the things that we're going to be working with are very large, such as the distance between stars, and very small, such as the distance between atoms. The powers of 10 for large numbers are things such as 10 to the first, which is 10, 10 to the second power, which is 100, 10 to the third power, 1,000, and 10 to the fourth power, 10,000, and so on. One power of 10 that many people do tend to overlook is that anything raised to the zero power, in this case 10 to the zero power, is 1. We are going to use these powers of 10 to help us write numbers in scientific notation. Let's try some examples. We have two. One where we're going to take a number, 52,000, and write it in scientific notation, and take a number such as 4.5 times 10 to the sixth and write it in standard notation. Let's start with the first example. The first thing that you want to do is you are going to put the decimal point between the first two numbers. In this case, 5.2. You will always end up with a number that is bigger than 1 and smaller than 10. So you shouldn't end up with something like 52. Next, we're going to put in the times 10. And then we need to count how many places we moved our decimal point. Now when we look at the 52,000, it does have a decimal point. It's just not showing. It's really 52,000 decimal point. Then, when we had moved the decimal point between the 5 and the 2, we had to move it 4 places. So our power is going to be 4. Notice that that power is not necessarily the number of zeros that we removed. It is, though, the number of places that we did move the decimal point. Let's look at the second example. We have 4.5 times 10 to the sixth. To put that back into standard notation, we first put down the 4.5. Next, the 6 tells us how many places we need to move the decimal point to the right. So, in this case, we move the decimal point to the right 6 places, giving us 4,500,000. Once again, notice that the power is not necessarily telling us about the zeros. We don't have 6 zeros. Had we placed 6 zeros, we would have ended up with 45 million, a number very different from 4,500,000. Some important points. The first is that remember that the decimal always goes between those first two numbers. We should always get a number between 1 and 10. Second, when putting those numbers back into standard notation, the exponent does not necessarily tell you how many zeros there are. It may in some cases, but in essence, it really tells us how many places we need to move the decimal.